Hello everyone, this is Sangeetha, Assistant Professor EC Department, SNS College of Engineering. So today's topic we are going to study about circular buffering. So in the last video we knew about the digital signal processor. So just a small recap of digital signal processing so that it will be useful for studying circular buffering. As digital signal processor is a specialized microprocessor for the kind of algorithm employed in digital signal processing. So the main goal to accelerate the calculation while keeping the power consumption as low as possible. And circular buffering, and coming to the circular buffering, it is a technique commonly used in digital signal processing used to efficiently implement data buffering, particularly for real-time processing applications. It involves using a fixed size buffer that wraps around when it reaches its end, creating a circular data structure. This enables continuous processing of data streams without the need for frequent memory allocations or data movement. So let us discuss how circular buffering works in DSP. So the first one is circular buffer initialization. Buffer set, that is, first a fixed size buffer is allocated in memory and it is initialized. A circular buffer is typically implemented as an array of fixed size. In DSP applications, the buffer size is often chosen based on the processing requirements and memory constraints. Two pointers are used to keep the track of the read and write positions. So these pointers are initially set to the start of the buffer, and the next process is writing data. So as a new data arrives, it is written into the buffer at the position indicated by the write pointer. After writing the data, the write pointer is incremented. If the write pointer reaches the end of the buffer, it wraps around to the beginning, allowing for continuous writing without wasting memory. And about reading the data, when data needs to be processed, it is read from the buffer at the position indicated by the read pointer. After reading the data, the read pointer is incremented. Similarly, if the read pointer reaches the end of the buffer, it wraps around to the beginning. So and the main thing is data acquisition, as the data arrives from an external sources such as a sensor or an ADC. It is stored in the circular buffer. So the write pointer is incremented to the next available position in the buffer. If the write pointer reaches to the end of the buffer, it wraps around to the beginning. So create a circular behavior. And the data processing, the DSP algorithm read from the circular buffer for processing. The read pointer is incremented to retrieve the next set of the data samples from the buffer. Similarly, if the read pointer reaches the end of the buffer, it wraps around to the beginning. So buffer full and empty condition. How we can check? Suppose we want to determine if the buffer if the buffer is full, the write pointer and the read pointer are compared. If they point to the same location, the buffer is considered full, and further data acquisition will overwrite existing data. Similarly, to determine the circular buffer is empty, the write pointer and read pointers are compared. If they are equal, the buffer is considered empty and no data is available for processing. And for continuous processing, circular buffer allows for continuous processing of data streams without interruptions. As a new data is acquired, old data is overwritten in a circular manner, ensuring a constant flow of data processing. And the circular buffer is widely used in DSP application such as audio processing, speech recognition, digital communication, and real-time systems where a continuous stream of data needs to be processed efficiently in real time. Hope this video will help you to understand the basics of DSP and how the circular buffering is carried out in DSP. Thank you.